Hello everyone, welcome to episode 15 of Reconstructing Cave Story. In this episode, we're going to be introducing the background. Well, the problem is, I'm tired of staring at this dang black background. It's pretty boring. Let me show you what it looks like right now. It's pretty boring. We could just paint it a solid color like blue or something, but and Pixel actually does do that for some of his levels. He just paints it a solid blue color, but we're not going to do that in this episode. In this episode, we're going to add a tiled background, or backdrop is what I'm going to be calling it. And at the same time, we're going to add some background tiles. So let me get into that a little bit more. So there's a few different layers that we're going to be looking at. Right now we have a foreground layer and an entity layer. The foreground layer will just have the wall tiles, the water tiles, and pretty much anything that gets drawn in front of quote, or closer to the player than quote. And then the next layer back, it's basically the foreground layer is the closest stuff to the camera. So the next layer back is the entity layer and layers, where you have stuff like quote, the enemies, doors, and save points and stuff like that. One layer back, though, is what I'm going to call the background layer. This background layer is going to have background tiles, like chain tiles. So like sometimes you'll see chains holding things up and you can walk past them, or like the buildings are background tiles in the main village area. So yeah, you're going to get a lot of those, especially in small rooms. The whole area will be filled with background tiles and some wall tiles. So those are all tiles, but then there's this backdrop stuff, which is the stuff that's in the way distant background. And this can be, sometimes it's going to be a solid color, sometimes it's going to be a cave texture. And I actually have an example because I added a new thing to my content folder. It's this BK blue, and it's just this blue texture, but it looks like rocks in the background, and it gets tiled next to each other, filling the whole screen. But actually, this backdrop can get more complicated because it can be either just fixed position where it doesn't look like it's moving at all, or it can have some sort of parallax effect where it looks like it's moving at a slower rate than the foreground, so that it looks like it's further away. And then other times it's just scrolling by on its own when you're in, say, a boss fight but you're underwater and you're fighting this giant fish, and the background is scrolling by really fast in the background. So there's the backdrop layer. So we're going to be getting to the backdrop layer. We're going to just do fixed position for this episode. And we'll also do the background layer, which includes some background tiles. We'll just make a chain to just make sure that it's working. So, without any more talking, let's get started. So let's start with our backdrop. And our backdrop is going to have an interface and several subclasses or implementations of that interface. I guess not subclasses, implementations. So we'll create a new header file called backdrop.h so I can show you what I mean. So usual header guards and def. All caps. And I'm going to just go ahead and put all the implementations in this backdrop.h file for now, just because I don't really feel like I need to have a bunch of files to manage this. So our first backdrop that we're going to be making in this episode is going to be a fixed backdrop, one that doesn't move with the player or the camera. And so this is going to derive from public backdrop. Cool note about structs is, since they're public by default, you can actually eliminate this public and it would work fine. So, but I'm going to leave it in. And that's because backdrop is a struct, not fixed backdrop. But yeah. So what am I going to start with? I'm going to start with making a virtual void draw method, and this is going to be a abstract method or pure virtual void method, one that doesn't have an implementation. So I'm going to make this take in a const graphics and have it be const because it doesn't actually affect our backdrop. And then again for our fixed backdrop, we're going to have a draw method. So I'm going to include our graphics and not for declare it because we actually need to use the surface ID from our graphics because we're not going to be holding on to a sprite. In this case, we're going to be holding on to a surface itself, kind of like our sprite does. So this acts as a sort of sprite class. But I'm going to put this in the fixed backdrop class just because the other backdrops have more than one sprites and more than one image that they load in. So since fixed backdrop just has one, we can just have a private variable that we're going to call surface ID, and we'll call it surface ID. That's what we'll call it. So we'll need a constructor for fixed backdrop since we have some data that we need initializing. We'll call it fixed backdrop because that's the only thing we can call it. And it's going to take in a path. And it'll also take in a graphics because it uses the graphics objects to load in graphics, which won't be const because, well, it stores it in the graphics class. Surface ID, so that's where that's going to get loaded in. I need to also include our string class so that we can use it successfully. And I'll go ahead and add a new CC file so we can start implementing this. So backdrop.cc. And we'll pound include backdrop.h. See how it likes everything. Everything looks good. So let's start with these two methods, or this. We'll start with the constructor for now. So we'll copy and paste that in and scope it in. Fixed backdrop. And see what it doesn't like, and it likes everything just fine now that I've finished typing. So let's set our surface ID to be equal to graphics.loadImage, passing it in the path. Sweet, that's all there was to that. I could even do this inside of here, but since it's a function call, I'm putting it inside here for random style reasons that I don't know if I'll be consistent about. So whatever. Now let's implement draw for our fixed backdrop. Remember, we're not actually implementing it for our backdrop itself because this is a pure abstract class. It doesn't have any implementation. So we're redeclaring it, so let's define it instead of redeclaring it. So what are we going to want to do with this? So for this, we're going to want to, we're going to want to know how big our image is. And if I bring up the properties for BK Blue, we can see that the image size is 128 by 128 pixels. And that's how big all the backgrounds are, except for one. And I haven't figured out where that background is used yet. So we're going to just assume for now, because we can, and we can change it later when we need to, that all background images are 128 by 128. So I'm going to document this by saying we have a const int K background size equals 128. And this will be in pixels. So what we're going to want to do is we're going to want to loop through our screen size, our screen width, and our screen height, filling it in with these K background size by K background size surface IVs. So in order to do that, we're going to need to know our screen width and screen height. So I need to factor that out in game.h, but for now I'm going to use magic numbers because I just want to get this part coded in. So we know that our screen width is 640. I'll just use constant screen width equals 640, and our screen height. So this is duplication for now, but I'm just doing this because I don't want to interrupt the flow right now and factor out the 640 by 480, but we'll do that in this episode, so it'll be fun. So what we're going to do is we're going to loop over the size of the screen. So we'll start with x equals 0, and then x, while x is less than 640, we'll keep going, and then we'll say x plus equals, and this is where it's different from a normal for loop, and this will be the K background size. And this is how we're going to loop through and do the whole screen. And we'll do the same thing for y, except I'm going to replace this 640 with screen width. Sorry, just made that constant too. Y is less than, and we'll do screen height. And then y plus equals K background size because it's a square. So what we're going to do for this is just a simple draw, graphics.draw split surface, JK, split surface, passing in the surface ID, which is just going to be surface ID, and passing it in the source rectangle. So since we want to cover the whole thing, a quick trick to do that based on the documentation is just pass null for the source rectangle, and then we'll need to actually use our destination rectangle, which we'll define in a second. So we'll say SDL rect destination rectangle and destination rectangle dot x is going to be equal to x, and destination rectangle dot y is going to be equal to y. So what is it complaining about? Oh, so it doesn't like split surface doesn't require const graphics, and that's because I wasn't being careful. So I'm just going to get rid of these consts to make it easier on myself, because I know I won't use graphics where it shouldn't be used, so it'll be fine. But yeah, your consts have a way of propagating. Let's see. What is it not like now? Oh, I got rid of the const in the wrong place. Oh, and I'm in insert mode. So I need to also include SDL, because I'm using that SDL rect, that wonderful SDL rect. And I'm only using the x and y again because the width and height are ignored. So this should be all that we need for our draw method. So now that I've finished that, I'm going to go ahead and factor these out of the game class. But before we do that, I'm going to go ahead and build by pressing F7. Let's see if there are any errors, and there seems to be one error. That's that unresolved external symbol for draw. Oh, and it's expecting a draw because I didn't put an equals 0. So this is what actually makes this virtual, or pure virtual. So that should fix that error. Let me try building again, make sure everything's just compiling because it should be. And it is. So now we can move on to factoring out those constants from the game class. So right now the constants are being used in our graphics CC class. We have this case screen width and case screen height, and we don't want these inside of the private namespace of the graphics, and I'd rather have them inside of the game class. So I'm going to open up the game class, game.h, and just like we have our static int k tile size, we're going to have another couple of static ints, so k screen width and static int k screen height. And I'll actually define these alongside of our tile size. So this will be k screen width and k screen height, and this will be 640 by 480. And so inside of our graphics class, we can, instead of using these k screen width and k screen heights, we'll scope in from our game class. So I'll pound include game.h and scope it in like we do our k tile size. And that should factor it out nicely to the game class. So let's use that inside of our backdrop instead of using screen width and screen height. So let's include game. Down here below, our library includes. So this will be game k screen width, and this will be game k screen height. So let's build to make sure that this is all happy. Are we happy? Yeah, we're happy. So now let's incorporate this into our map, our test map, so that we can actually see what this beautiful backdrop looks like. So let's open up our map.cc and our map.h as well, because we'll also need to have a pointer, smart pointer, and I'm going to make it not standard but a boost scoped pointer to our backdrop. And we'll need to include a couple of things as a result, and we'll just call this backdrop. And then in our test map, we'll initialize that backdrop. So we'll need to forward declare our backdrop. And actually, I'll just go ahead and include it. It's not that big. And I have gotten complaints from shared or scoped pointer when I don't include the files, and I don't know how to fix that yet. So if anyone knows how to fix that, I would love to hear about it. And that's just, I get errors if I just forward declare it, and then I even include it in here, but yeah, I won't go into that. So yeah, so let's initialize our backdrop in our create test map, and so we'll do that just at the top because I can. Dot reset. Oh no, I need to scope it in, or not scope it in, but use maps backdrop. Dot reset. And a new fixed backdrop. Because remember, backdrop isn't really anything, and we can pass it in a path, which is going to be this bk blue. So I'll use content bk blue dot bitmap, and we also need to pass in our graphics. And it's a good thing I didn't make that const, because our graphics right here is not const. Too many arguments in function call. Well, that's because I closed off too early. Yeah, up there. Okay. So yeah, now we have our backdrop, but we need to reset it, or no, we need to draw it now that we've reset it. But we can't just draw it in here, because then it would get drawn on top of everything, and in particular it'd get drawn on top of quotes. So actually I'll just show you what it looks like just for fun. So I'll do backdrop, draw, passing it in the graphics, and let's see how this works. Yeah, so as you can see, we can't see quote anymore. I mean, he's still there, but he's getting drawn behind the backdrop. So let's break out another method in our map class called draw background, and this will get called before we actually draw quotes. So let's call this draw background, graphics. This will be const, and let's just implement it with a simple map moving of this line into here. So now we have this line in here. Let's actually call it in our game CC file, and so we'll call it down here in draw before our player actually gets drawn on the screen. So we'll call map draw background. And I didn't call it draw backdrop because we're going to be drawing a background later too, our entire background. So let's see how this looks. And this should look better, but not perfect, because as you can see, quote is actually drawing his black pixels as well. And you weren't noticing it before because, well, he was either drawing behind these foreground tiles or he was drawing on a black background, so it was impossible to see. But now it's time to actually eliminate this problem. So I'm going to do that. Boom, with an escape. And so in order to do this, there's a trick that SDL has. I don't know if I mentioned it. Yeah, it's this SDL set color key where you can choose a surface and then say, hey, ignore all of these colors, and then or ignore this particular color and pretend like it's transparent, and then you pass it a color. So pixel shows for us and it's black. And so let's go ahead and implement this in our sprite class, because it's always, he doesn't ever use black, but these are the only transparent sprites. So right here is where we need to change things, but since we don't have, this is just a surface ID, and we could change this to just a regular integer instead of a pointer sometime in the future. So I'm going to make the change in our graphics class, and I'm going to do it in an interesting way, I guess. Maybe it's not that interesting. I'm just going to add a bool called black is transparent. And I'm going to default it to false. And this means I need to fix graphics CC, which is down here. So bool black is transparent. And so I'll just do it whenever I load it. So if black is transparent, then what I'm going to do is I'm going to call SDL set color key, and that's going to take in this surface, so sprite sheets subfile path, and as well as a uint32 flag. And so if flag is SDL source color key, then it's going to hide this color or not draw it, and that color we're going to use is black. So now in our sprite CC file, all we need to do is pass in black is transparent, and we'll define this to be some constant or const bool. And for the rest of the cases, black isn't transparent. So let's see how this works. All right, there we go. So now the black pixels are transparent, and so we can see, we don't see a nasty black square around quote. So I think I'm actually going to stop the video here because we're getting into the 20-minute area, and I'll implement background tiles in the next episode, or part 2 of this episode. depending on how I feel like naming it. So thanks for watching, and happy developing, I guess. Yeah, that's a good outro, right?